So it's truly a pleasure and an honor to be able to be here this afternoon to celebrate Clark's legacy. It's also been a delight getting a chance to reconnect with a number of students and colleagues, many of whom I haven't seen for many, many years. If you can go back, let's see if I can go back. There we go. So I joined MIT's PhD program in 1980. That was 2 years after Clark had finished a significant collaboration with colleagues at Amicon on the development of a membrane filtration system for the separation of blood cells and blood plasma. And some of you may recognize Barry Solomon's name and Mike Lysat's name, two true leaders in the field, as well as Eli Friedman, who were collaborators on this project. And they published this work in the SIO journal. And you can see that two of the conclusions taken from that paper was that the filtration velocity as well as the extent of hemolysis were in very poor agreement with existing theories. Well, when I joined MIT in the fall of 1980, Clark decided to offer this as a PhD project. It really caught my interest because of the integration of the biomedical as well as the chemical engineering aspects. To the best that I can remember, Clark's instructions were basically, here's the paper, all the models didn't work, figure out what's going on and come up with new theories that do work. And so as a new, eager PhD student, I threw myself at this and tried to solve both of those. And somewhat amazingly, in hindsight, less than a year and a half later, we published our first co-authored paper, also in the SIO journal, where we had new models for both the filtrate flux as well as hemolysis that did a very good job of predicting the behavior that had been observed experimentally, not only in Clark's work, but in a number of other studies that had been done in this general area. Clark got really excited about my thesis work. It was a delight to be able to see that. He ended up presenting at some of the work that I had done, both at a Gordon conference as well as at a major international meeting in Compiègne, France, that Clark was generous enough to allow me to come along to. The coloring is a little dark because it's taken from an old 35 millimeter slide that Clark probably remembers. I couldn't remember the name of the art company that did this. Abdul, thank you. That was Arco. I think Clark spent more on the slide deck than my entire year's stipend as a graduate student in chemical engineering. But it was a delight to see Clark present on that work. I joined the University of Delaware in 1985 and decided that I would sort of leave the biomedical work for Clark and put the focus in my lab on membrane processing, and was motivated in part by some of the work that had come out in the membrane community demonstrating that although membranes were an incredibly valuable technology, there were challenges and they never were able to achieve the performance that the field was looking for. And so that was the motivation for my research program. I kept the bio part, but we decided to focus more specifically on bioprocessing and the purification of high-value biopharmaceutical products. Looking back, one of the first real breaks that I had in my career was that I got to both chair a session and present at a meeting of the Recovery of Biological Products, which is the premier and is still the premier conference in the area of downstream bioprocessing. Clark was chairing that meeting, demonstrating his importance not only to the biomedical community, but also to the bioprocessing community. This was back in 1990 at an absolutely gorgeous resort in St. Petersburg. Clark managed every single detail of the meeting. It was just extraordinary. And you can see that I was co-chairing this session with Bob Bratzler, and one of the other speakers was Tony DeLeo, two other alums of Clark's group. And this led directly to some major collaborations that my lab was able to pursue in the bioprocessing area. We decided to focus in part on selective membrane separations and seeing if we could push the envelope and how membranes could be used for very fine separations. And this was, again, motivated by some work in part done by Alan Michaels, one of the true leaders in the membrane field with applications in the bioprocessing area. I wish I had time to go into more details, but this isn't the right forum to do that. But in collaboration with colleagues at Genentech, we developed a fully membrane-based process for purification of monoclonal antibodies, where we avoided using chromatography altogether. We've looked at the separation of DNA isoforms, looking at how one can use membranes to separate supercoiled and linear DNA with the exact same number of bases. This is actually an elongation-based separation that exploits differences in elongational flexibility of the two isoforms. More recently, we've moved on to RNA as well as adeno-associated virus. And again, this is a fully membrane-based process for the purification of AAV. I thought I would take the last minute, since I haven't gotten my warning yet, to tell a story about Clark that I think in some ways is very representative of who Clark is and how he tended to function, at least at the time that I knew him well. This is probably a story that Clark doesn't remember, but it dates back to the very first professional conference that I went to as a junior faculty member, so in 1985. And I was, the conference was, again, an ASIO meeting held down in Atlanta. I went with my wife. We were without kids then at that point, so we were able to attend. And Clark was scheduled to present in a significant panel session on the afternoon of the first day of the conference on bioartificial organs. So I get a call, left a message in my hotel room on Saturday night. Clark has been traveling. He's going to arrive in Atlanta at noon. His talk is at 1:30. Could I pick up blank transparencies so when he arrived at the hotel, he could put together his slides for his afternoon panel session? Of course, as a dutiful former student, I spent part of the day on Sunday in Atlanta trying to find somebody who could sell me blank transparencies. I managed to get a hold of them. I left them at the front desk of the hotel. Clark arrived at the panel. All the panelists were sitting in the front. He wasn't the first speaker. I could see him with his colored pens filling out the transparencies. And as is typical of Clark, he gave by far the best presentation in the panel. And I don't think anybody realized that the slides were truly hot off the press. They were made literally minutes before he started his talk. But he did an exceptional job. With that, I will conclude. I do want to thank Clark for all of the support that he's provided over the course of my career and for really being a true inspiration for a lot of what I've been able to do in my lab. So thank you, Clark.
Thank you for the opportunity to speak today. I call the title of my talk, Journey from Dialysis to Rare Disease, because this reflects my both my professional path and also the lasting influence Clark had on my career. To begin with, I'll go to the next slide. So before coming to Boston, I was working on my PhD. I finished my PhD with Professor Colton on membrane separation for gases. But I wanted to apply separation sciences to biomedical engineering. And I asked Clark to meet with me. And I contacted him. He decided to meet with me. And I entered his office, and I saw a sign that said, I'll make you an offer you cannot refuse. There was a sign, I don't know if any of you remember the sign on his, I'm sorry? he was very charming, very engaging, and I immediately decided to work in his lab. And um, it was, to me, it was intellectually very challenging working in Clark's lab. He always asked hard questions. He assumed that you knew the background, you knew the mechanism of action, you knew everything. I had to catch up very fast. And and he also was very precise about technical writing, and he hardly ever praised. It was very rarely he praised you. And I did write a paper with him, and he returned the draft. It was completely red, and with a lot of corrections in it. But he did say to me that you had the content, but it's not presented well. I was happy with it, you know. So to me, when I wrote a paper with him, the thing about writing a paper with him is like you understand the entire field and you understand the relevance of what you're doing. So you learn a lot by writing with him. And the way his mentorship, like he kind of like his standards were very high, and it like pushed me to become better. I basically worked pretty hard, and I gained confidence and independence and understood the mechanisms deeply. His training stayed with me forever, and also in the work that I continued to do at Baxter and other places. And this was like some fun work that we did at Baxter. So when Clark Colton met Jeffrey Platt, xenotransplant was a hot area at that time, and hyperacute rejection was a major issue in the field, and which caused, we did know that xenoreactive IgM that all of us have causes hyperacute rejection. And Clark was very smart. He immediately said, we can solve this problem with membrane. And we decided to write a proposal to Baxter, and Baxter decided to hire me instead. Along with Clark, who was a consultant to Baxter, we developed an immunoaffinity membrane that Andrew Zidney talked about. We used a plasmapheresis membrane, functionalized it with some of the things that I have worked with Mike as well. We did a lot of functionalization of membrane and attached protein A to it. We kind of, instead of protein A, we attached the antigen, which is alpha-1 gal, to remove the xenoreactive IgM. And we showed in baboons that if we remove the xenoreactive IgM, we can prevent hyperacute rejection. And this was very exciting. And this wouldn't have happened if Clark didn't have the insight into that membranes can be used for separation of xenoreactive IgM. And so one of the things that remained with me is the framework. He always asked hard questions, transport, selectivity, mechanisms, and clinical relevance, and stayed with me at Baxter through xenotransplantation, dialysis, a lot of cell therapy work that I did. And in Renalysis, we set up a dialysis plant in China and registered a generic product. And also in orphan disease, the same principles apply. You can see that in Wilson's disease, chelating agents bind to copper in the blood and promote its urinary extraction through the kidneys. Is also a separation problem, transport problem. And we did a number of interesting stuff with membranes at Baxter, regenerating dialysis solution, coming up with urea sensors, selection of CD34 positive cells for MI, dual lumen catheter design. So several of the things we did. And what Clark taught remained with me forever. On a personal note, he not only had influenced me in the scientific world, but also he introduced me to a lot of collaborators and opened the door for me. I met with them and I worked through all of these collaborators. He gave me a lot of independence, and he made me feel that my work mattered. And my career has been deeply influenced with his approach to research and application. And I have a lot of fond memories with Clark while at MIT and later on as well. And I would like to thank Professor Colton, who offered me more than a postdoc. He offered me a way of thinking, a network of people, confidence in my own voice, and a career path I could not have yet seen for myself. And I really am deeply grateful for that. And finally, I wanted to show this slide with one of his graduate students, Susan Lesner, that baked a chocolate cake for him for his 50th birthday. This was his 50th birthday, and with raspberries and marshmallows. And Susan, I think, is the only one, at least when we all were there, he didn't do too many corrections on her writing. Everybody else got red lines, except for Susan, who, didn't get that. Thank you so much, Clark. And
Hi, everyone. And now for something a bit completely different. I'm Mike Pomianik, and unlike most of the folks who have spoken so far, I'm not going to be going into heavy science or all the research that I've done since leaving the Colton lab. I migrated into the legal field and have been a patent attorney at Wolf Greenfield and Sachs here in Boston for the last 30 years. But I think what I'd like to present today is really the way in which the lessons that I learned in the lab and Clark's influence have carried over with me even to this other field. I mean, patent law it's not doing the science, but it's commercializing, and it's really reflective of the application of science to practical problems. And I think Clark, being a pioneer in that field, really helped me to see that being a career that was one that I could make a major impact. I also will present a little bit just to show we saw a lot of talk about how Clark is a pioneer in the biomedical field, and how the impact that's made on people's lives and commercially can be reflected in patents, which are really a reward for innovation that has practical and commercial impact. And we'll see what a major impact that the Clark family tree has had. So just a very little bit of background on my trajectory and where I came from. So I'm a first-generation graduate student. I'm really a first-generation undergraduate student. My family my father was a Polish immigrant and the first in my generation to go to school. I grew up in New Jersey and went to my local school, Drexel University in Philadelphia. I didn't come into MIT knowing very much about research or academia, and really with a fairly modest pedigree. So, but I was interested in doing something that would have an impact in people's lives, and I had done research to understand that Clark was one of the leaders in that field of applying science to medicine. So I gravitated towards his lab, and whether it was because Clark had a lot of trust and faith in me, or whether it was because I had perhaps a limited pedigree, I had sort of an unusual trajectory in the lab in that I had projects that weren't directly associated with what everyone else is doing, but they were kind of one-off projects, and ones that were, I ended up with two projects, ones that were not particularly well-funded. They were sort of outliers. My first project was looking at the effect of fluid dynamic shear stress on immune cell regulation in things like extracorporeal circulation. So I worked with some folks at Tufts University School of Medicine and studied the effect of shear stress on the production of cytokines to figure out why people who are on blood circulation devices like plasmapheresis devices and extracorporeal circulation often suffer deleterious effects. And then that project completed very successfully and rather quickly. We had a paper published in the SIO journal and really pretty much completed everything we wanted to do there. Clark, however, as I'll go through in a couple of the lessons that were learned, was not going to let a student graduate from his lab with a PhD in under 3 years. So at that point, I reset and did a completely different project. The second project, I remember asking Clark, do you have anything else that I can do if you don't think that I've done enough to finish at this point? He said, I don't have another project and I don't have any funding, but I have an idea. I'm not sure if it'll work. And if you want to figure it out, you can do it. So that started my second project, which took about another 6 years, which was using immunoaffinity membranes with functionalized with cell receptors to figure out whether or not we could bind and release cells effectively. I've been told I have a minute left, so I'm gonna. So we ended up publishing a paper from the first one. This is my thesis, which was primarily about the second project, the selective cell separation. So I still, even though I'm a lawyer, I still use my thesis work and my thesis and my chemical engineering every day. Very practical. But seriously, you can see also how thick, we were talking about how long theses are. You can see how thick my thesis was. I think it's up in the 600-pager. But just quickly, and two things I want to accomplish before finishing. One is just to go through a few lessons that are learned and how they apply even in my role as a patent attorney. So a couple of things that happened. First, a couple of professional lessons. The first one was the first thing I handed Clark to review was my thesis proposal, and it was the abstract for my thesis proposal. And similar to Sujatha, what I got back was something that was completely X'd out and another thing that Clark had done. And the only comment on it was that I've rewritten it, this time in English. So Clark could be a harsh critic and a harsh editor, but from that, I learned that, and also his fixation with figures and with figure labels and with tick marks inside and outside. What I learned from that is that the impression that you make, the professionalism that you make really is important, and it's not just the content, but it's also the way that you come across. And if you come across as being sloppy or imprecise, you're going to not get the same credibility in the field that you would have otherwise. And I apply that right now. Patent law is a service business. Clients expect to have polished product, and it certainly influenced my ability to make a good impression in my current career. The second one was that transition from the first project to the second project. Clark said when we published in the SIO journal and pretty much said I think I'd done everything that I wanted to do in my proposal, is that it's great that you finish completing your project in 2 years, but that's not enough for an MIT PhD in my group. And what that taught me is that success requires efforts and that expectations are high, and that there's a certain amount of work that you have to go through in order to show that you've done enough to really prove that you've accomplished something that is worthy of the title that you're going to be conferred. So from that, I think I've just learned that in my line of business that there's a practical and commercial value to what innovation is, and that you really have to really make sure that you have put in all the work and that you've accomplished as much as is required to really bring things to fruition. The last thing is I don't have another project or funding, but I have a unique idea that might make it work. It'll be huge if it does. Well, we spent, on that project, we had to build everything from scratch. We had to go to Seprecor to figure out how to make the membranes, had to go to Dana-Farber to figure out how to deal with cell cultures and figure out how to functionalize the membranes. We had limited resources, and I ended up TAing. I think probably I may have taught more courses at MIT than most professors do by the time they get tenure. Throughout the 90s, I was a TA for Clark in the undergraduate laboratory course that was mentioned. So that lesson taught me resourcefulness. It also taught me we succeeded really well at the beginning in a pilot phase, showing that it worked extremely well. But when we tried to scale up, it didn't work. And we spent the next 2 or 3 years figuring out why it didn't work. And we learned a lot about biophysical cell deformation at small length scales through that process, which really was insightful and was something that I think was very helpful for furthering the project and learning a lot about cell membrane behavior that wasn't understood before. On the personal side, the Colton lab was always like a family. We had, I can remember spending time on the beach with Clark, doing slides and really just having his time commitment being one that was important. And that stuck with me both professionally and in terms of keeping in touch with everyone here. And Clark's always had a relentless focus, as others have said, on solving engineering problems. So the last thing I want to do is just I was introduced to patent law because we had a patent application that we filed through my second project. Clark's still inventing. We still do work for the Colton lab. Here's a patent that he filed on stem cell separation, another one on cannabis. So his interests are quite varied, from stem cells to reefers and weed. The last thing I want to wrap up with is just what an absolute juggernaut the people in this room and the Colton family tree have been in terms of its impact on commercialization of medical and biomedical technologies. This family tree has generated over 1,300 patents, and that's Clark, his students, and the students of his students. If you look at that across the field, typically 1 to 3 patents per inventor is typical. In Clark's instance, it comes out to basically hundreds of patents have come out of his lab. Entire engineering schools, typically 200 to 300 patents, whereas in the Clark-Colton family tree, over 1,300 patents. The conclusion is that the Clark family tree is, by any reasonable comparative metric, one of, if not the most patent productive academic lineages in the history of U.S. engineering, and certainly the most productive lineage in the history of U.S. chemical engineering, so just completely unprecedented. We do more work, by the way, Wolf Greenfield, than any other law firm for MIT and for the family tree. We have several MIT alums in our firm, including another family tree member, and Tani Chen, who's a shareholder worked for Bob Langer. And the last thing I'll say, the most important thing I took away from MIT's, while Clark's influence and Clark's legacy has been very impactful for me, I met my wife, who was a 5-year student in the MIT practice school the first year. We've now been married for 35 years, and I have 5 sons. The oldest one just got his PhD from BU 2 days ago, and Bob Brown was the commencement speaker. So it's really come full circle for me. And with that, I want to thank everyone for the invite, and thank you so much, Clark, for everything you've done for me.